Hello and welcome to today's session on software architecture, and we'll talk briefly about mobile app development strategies. Um, so let's get started. So, what are some basic mobile app development strategies or approaches, if you will? Generally, if you're looking to build a mobile app, you would be picking between one of three potential options for doing that. The first one is not really a mobile app as we know apps to be, as in being able to download it from an app store. So the first development approach or strategy might be building a responsive mobile web app. Right, a responsive mobile web app would involve using HTML5, CSS3, and JavaScript framework of some sort. Right, so those are front end technologies: HTML, CSS, JavaScript, to drive the design. Basically, the goal is to build a mobile friendly web app solution that can, run on a mobile device and look as though it looked pretty close to a mobile app, but it might not be a native mobile app in that sense. So, responsive mobile web applications are accessible through web browsers. If you don't know what a web browser is a client that allows you to get to browse some web pages, right? So, client software that you can install to access a website would generally be fall in that category. Some examples would be Microsoft Edge, Microsoft Internet Explorer. You've got Chrome, Firefox, Safari, so on and so forth. Native mobile apps, though, are probably the most popular type of app development approach that we know of. That typically created for a specific operating system. So if we're building an app for Android, Android would be considered an operating system. iOS is an operating system, right? So we're building an app that would run on Android. Would typically use the programming language called Java, or more recently, you'd run into programming language like Kotlin. If we're building an app that would run natively on iOS, then we'll be using Swift or Objective-C. Objective-C is a little bit older. Swift is kind of the norm these days, right? And so they would have specific SDKs or software development kits that are native to the device, so you can tap into things like GPS on the phone, right? Some of the capabilities of the phone are not possible to use if you're building a responsive web app, for example. But if you're building something that needs to take into consideration some of the capabilities of the device, of the mobile device, then you'd be thinking of native, for example, right? All right, so next is cross-platform solutions. So cross-platform solutions are sometimes referred to as hybrid apps. So the idea is that you would use a technology like React, PhoneGap, Xamarin. Those are platforms that allow you to build an app code once, but then get it to run on multiple operating systems for mobile. So instead of writing an app with Swift for iOS, writing the same app with Kotlin or Java for Android, I would write my code once with JavaScript, for example, using the PhoneGap platform, and then PhoneGap would be able to produce a native version of it that goes in the Apple App Store or the Android Google App Store, right? So the idea is that you write the code once and it's available on multiple platforms, where I would refer to it as cross-platform. It's more of a hybrid approach. So those are some of the key strategies for building an app. Obviously, if you're trying to build something that's going to be really fast, needs the full capabilities of the phone, you want to go native. You could use responsive mobile web app as an interim solution. Some solutions would have both, right? So when you're building your website, just make it responsive to start with, but it doesn't mean that you can't build a native app, right? If you want to build an app that's going to be really high performance, as in it's going to run really fast, sometimes you might need to pick native over cross-platform, right? Let's talk about some highlights about responsive UI. So responsive UI would use HTML5, JavaScript, CSS. You could use a capability of CSS called media queries to make the website more fluid and flexible based on the size, the screen size. If it's a website, it'll look something like this on a PC, but then the same website, when you access it on an iPad, some of these structures would rearrange to form something like this. And then if you access this on a smaller form factor mobile device, it would look something more like this, right? So those are some examples. HTML5 or HTML is short for Hypertext Markup Language, provides a structure of the web page. So how we structure a web page, HTML is used for that. CSS is typically used to add skin and makeup, if you will, right? So put in some lipstick on a website generally involves using CSS, right? So that's what's going to provide the look at, the actual colors and things like that. Making the web page look pretty is what CSS is all about. So CSS is short for Cascading Style Sheets. There's several CSS frameworks out there, Bootstrap, Foundation, so on and so forth. Bootstrap's probably the most popular that we would probably use in this course. JavaScript is the technology or programming language, if you will, that's used to make the web page interactive. Now, notice HTML, even though it's a markup language, it is not a programming language. So if you see that on a quiz, it's a hypertext markup language to mark up the page. JavaScript, however, is a programming language where you can write some logic, right? You cannot write logic in HTML. Some examples of JavaScript frameworks would be Angular, React, jQuery. These days, Angular and React are very popular. So you'd probably want to pick up on some of those technologies if you're looking to build responsive web apps. Native involves building multiple versions of the same app with different programming languages. So you have multiple teams, multiple code bases, different tool sets. It's a little bit more expensive to build a siloed native app than to build a cross-platform. Cross-platform app involves using one of these frameworks, so you build it once with one programming language, and then you can port it to multiple systems, right? Sometimes you can use JavaScript for cross-platform solutions. Here are some platforms: Titanium, Accelerator, Adobe PhoneGap, Xamarin, so on and so forth. Typical issues: performance for processor-intensive tasks. Cross-platform usually not the best solution for that, right? So you could think through what are some pros and cons of the different app development approaches, and you might find that useful when we start talking about some of the other concepts. Now we'll talk about enterprise architecture and solutions architecture.
All right, so let's talk about enterprise architecture. So enterprise architecture is concerned with creating a conceptual blueprint for structuring the operations of an organization, right? It might include software and business data, so on and so forth. Generally, our goal is to capture the current state of how things are interconnected or how things are working. And then sometimes we might capture the transitional phase and to the future state. So if we know how things work today and sometimes how we want it to work in the future, which would be the future state or the target architecture, we might have some way in which we do things in between called a transitional architecture, right? We'll document that in that form. Architectural domains are, generally there are 4 pillars for architectural domains. The business architecture, which has to do more with the business processes and standards for doing things day to day. And then we have something called software architecture or application architecture, which is what you'd hear of more often, which basically defines how different software components interact with each other, right, to support the business processes in the organization. Sometimes we would have a data or information architecture, which deals more with the raw data collection and how that's working together to make things a little bit more efficient. And of course, we might have infrastructure architecture or technology architecture, which has to do more with the hardware and the cloud computing network components of things, so on and so forth. So here's a hierarchy of those domains: business, data, application, and technology. Some concepts. So a system would be a collection of components. So we'd say this computer system, because the computer has multiple components to it. Stakeholders in general means people who are concerned about or involved with using a system, right? Concerns would be any interests that affect, us accepting a specific system, and views and viewpoints, have to do with people's perspective on some specific concern around something that we're doing architecturally. Here are some frameworks for managing enterprise architecture or implementing them. TOGAF is probably one of the leading frameworks, the Open Group Architecture Group. DODAF, Zachman frameworks. Those are all interesting enterprise architecture frameworks to look into. I'd encourage you to watch the video on why enterprise architecture on Canvas. Let's talk briefly about software architecture tiers. So when you have to put together a software architecture in this class, we're mostly looking for you to look at it more from a tiered perspective. Let's talk about tiers or different types of architecture. So you can have a conceptual architecture, a logical architecture, and a physical architecture. Generally for this class, we're mostly focused on the logical side of things. So conceptual would be high level. Hey, my website connects to PayPal, and PayPal connects to, some other, maybe I also have my website connected to Amazon to get something, so I've got 3 or so boxes that I draw to create a conceptual architecture. The next level of detail would be the logical architecture, which takes it down a notch to speak about the fact that, hey, my website has a set of web servers, and it also has a different tier for the data layer, and then, by the way, the web server tier is what's connecting to PayPal, and PayPal also has a data store, and that's an Amazon API that I'm connecting to, that type of thing, right? So for the sake of our discussions in this class, generally we're looking at more at the logical level. Now, software architecture could also consist of looking at layered architectures, and layered architectures would be basically separating out, hey, my presentation layer has the web site served on a web server, and then maybe I have some API or some business logic layer even inside of the website or separated from the website, and then I might have a data access layer or DAO. That comes into play when we're writing C# code or PHP code. You might layer your code into different layer components or categories, which helps with separation of concerns. There's a concept of, I can have a web designer or front-end developer work on just the presentation layer, and all they have to know is CSS, HTML, JavaScript, and they don't have to know C# or PHP to be able to work on that side of the fence, right? And then I can have back-end folks who work on the business logic layer, which is a different layer of the same application, and they don't have to know too much about HTML, CSS, JavaScript. They write all their code in C#, talk to some SQL Server, stored procedure, that type of thing. And then I could also have, database developers who are writing code in SQL Server, building triggers, building stored procedures and things like that, and they don't have to know anything about C# or JavaScript, meaning they're agnostic to the business logic layer and the presentation layer to a large extent, right? So that's a little bit about building layered architecture. For the sake of this discussion, we're mostly going to focus on physical tiers or tiered architecture, and tiered architecture talks more about how things are physically broken up or divided into sub-applications. So it would have like a client browser talking to a web server, which then talks to a database server, so on and so forth, right?